Good afternoon. Today is March 30th, and today we are going to cover the last shell scripting lecture. And so in this lecture, we're just going to cover material that can now be added to our shell scripts to make them much more powerful. Indeed, the reason why we will be using, or the reason why you will be using shell scripting as a system administrator is really for the features and for the technology that we're going to be talking about in this lecture. So let's take a look at the list of topics here. So the contents are, we're going to cover a few things this time. Standard communication channels is the first one. So these are the communication channels available to all processes in Unix and Linux by default, and we're going to use them to use or to extend the functionality of our scripts. So in the lectures, you've heard me talked about standard in, standard out, and standard error. That's these standard communication channels. So we're going to talk about them now in some detail. So that's standard in, standard out, and standard error. Okay. These standard communication channels are important because it allows us to create redirections and it allows us to use pipes. So redirection and pipes are going to be the topics after the standard communication channels, and so we can't understand how redirection works or how pipes are working if we don't have a grasp of these standard communication channels. The redirection and the pipes are really what allow us to use our shell scripts now as glue to create composite applications that bring many different commands and files and configuration files and all these sort of things together to make very complete and powerful scripts that actually perform useful tasks. We're also going to talk about the environment, and these are going to be certain variables that are available in the shell. We're going to cover it very briefly, and there's one particular environment variable that I have to mention, and in the future you may need to use it. So it is worth mentioning here. And then finally, we're going to talk about some useful commands and utilities. Essentially, I'm just going to be naming a few things that I highly suggest you read about, either through the man pages or using Google or finding a few books or watching a few other tutorial videos and so on. There'll be commands and utilities that will be invaluable to you when you are actually working as a system administrator. These are tools that get used all the time and have some really great features available to them. So first thing I wanted to talk about is the standard communication channels. So let's get started with that. Okay, so what are standard communication channels? Well, the way this works and the way this is handled on a very low level is by the kernel itself. So we're only going to take a very high level view of these sort of operations and these sort of abstractions. And so if you want more details, you can always, again, read about it online or look at certain man pages and so on. But we're just going to be looking at the purely functional aspects of this, or the things that are immediately useful to us. But underneath the surface here, there's a lot more interesting details going on. So first of all, every process has at least 3 standard communication channels associated to it. At least 3 communication channels. These are in order, actually, and we'll see why there's an ordering on them. Standard in, standard out, and standard error. So these 3 communication channels allow the process to send output or send information and to receive information from certain standard locations. And the processes usually inherit these from their parent process. So most processes have to be begun by some other parent process. So for example, when we run a command from from the shell, then that command's parent process will be the shell. That will be the process that launched this command. So processes usually inherit these communication channels, standard in, standard out, and standard error, from their parent process. So standard in, standard out, and standard error. They're very important communication channels. And so examples, these can be anything. They can be connected to a file, they could be connected to a terminal window, they could be even a network connection, or even a channel belonging to another process. These standard in, standard out, and standard error abstractions are just communication channels. They're not necessarily files. They could be sockets, they could be a terminal window, and so on. It's just some way to pass information from the outside of the process to the process, and from the process to the outside environment. So, and these are very much standardized, as we're going to see also. So every process has these three communication channels. Usually when that process starts up, they might be closed by the process later on, but when they're started, they at least inherit these three things. Okay, so or I should say, how does this work first of all? So every I/O channel in Unix or Linux is named with a non-negative integer called a file descriptor. A file descriptor is another sort of abstraction handled by the kernel to keep track of these I/O channels. So there's a bunch of data structures that the kernel maintains that tracks all of these file descriptors and associates processes to certain file descriptors, and also locations on disk if it happens to be a file or some other type of structure depending on the nature of the channel itself. But all of these input and output channels, all of these I/O channels in Unix or Linux, they're named with non-negative integers called file descriptors. So to the users, to us, we look at communication channels, in particular things like files that have a name, something human readable, but the way the kernel maintains these is with a number, a non-negative integer, and those are called file descriptors. And like I said, file descriptors are managed by the kernel. So for example, if you're creating a process or if you're writing a program that creates a new file, when that program is run, the file creation is handled by the kernel itself, which then will return a file descriptor to the process, and then however the process handles the file will be managed through that file descriptor. So the takeaway here also is the fact that these are managed by the kernel. So whenever we create a communication channel, we are asking the kernel to set up that channel, and then the kernel will say okay, or it will throw an error, something, whatever happens. And then if the process works, or if the communication channel is set up, then the kernel will give back to the process some integer representing the communication channel. And so then we use that integer, that file descriptor, to write to the I/O channel or to read from the channel, and so on. So the file descriptor for each of the standard communication channels are set. They're guaranteed for each process to have the same number. So the way this works is that each process have a list of file descriptors, which is then translated into a global file descriptor set, and so on. So we can assume, or the way that the kernel handles this, we can assume that for our processes, the file descriptors 0, 1, and 2 will correspond to standard in, standard out, and standard error, respectively. So in our processes, it is safe to refer to these channels, standard in, standard out, and standard error, by their file descriptors. So standard in, by default, is given file descriptor 0, standard out is given file descriptor 1, and standard error is given file descriptor 2. So these are just numbers that characterize or that determine the I/O channel. So for example, if our process is connected to just the terminal window for its standard in and standard out, 0 and 1 as file descriptors will describe that channel. And by using these file descriptors appropriately, we can read and write from the terminal. Standard error is another output, and traditionally Unix programs will print error messages to standard out, and oftentimes standard out and standard error are connected to the same place. But you just have to keep in mind that these numbers, these file descriptors, 0, 1, and 2 correspond to standard in, standard out, and standard error, and standard in, standard out, and standard error can be connected to some I/O channel. Okay, so for example, when we're working with an interactive terminal window, so if we're running commands in an interactive session with the shell, standard in is usually going to be connected just from the keyboard. And standard out and standard error are both going to write to the terminal window. Right? So standard in usually reads from the keyboard when we're working in the terminal, and standard out and standard error will write to the terminal window when they need to produce output. So programs will read from standard in by default and will write to standard out and standard error by default. And if these are connected to a terminal window of this process that was begun from a shell, for example, then standard in would read from the keyboard, connected to the keyboard, and then standard out and standard error would both be connected to the terminal window. So we've already seen many examples of this, in fact, this sort of setup here. Whenever we run a shell commands, or whenever we run an SH script, by default, those SH scripts have their standard in connected to the keyboard and standard out and standard error connected to the terminal. So when we use that read command, for example, in our SH scripts, then standard in, or really what's happening is that we are reading from file descriptor 0, which happens to be connected to standard in, which is in fact the keyboard in these examples in our SH scripts that we've seen so far. But we have changed this in the past. If you remember one of our scripts, I believe it was a script that reads or prints out the contents of a text file with each of its lines numbered. We had a line that was exec, and then we had 0 less than $1. This line, in fact, in that code, was changing file descriptor 0 to be whatever the first argument of that script was. So we were redirecting our input channel to be from the first argument, which happened to be a file in that example, right? So we can use the file descriptor in applications like this by using exec and so on, and you can read the man page for exec to get more information about it. It does many different things. One of them is changing these file descriptors. But really, like I said, we're only taking a very high level view of this because we need to know that there's standard in, standard out, and standard error connected to each process. And so then we can use them in order to chain certain processes together is what this is going to come down to, right? So every process, at least most Unix processes or Unix commands, are going to read their input from standard in, and they are going to write their output to standard out, and they'll write error messages to standard out. So what I mean by this is that right here, so many traditional Unix programs read their input from standard in, they write their output to standard out, and produce errors to standard in. So this is a convention that we are going to be following as well, and we can assume that if we use any built-in Unix programs, or if we use any built-in Linux commands, that they are also going to follow this very important standard. And so, like I said, it's best practice. It is the best practice to follow these conventions. So whenever we write scripts, they're always going to read their input from standard in, they are going to write their output to standard out, and they are going to write error messages to standard error. And most of this is already handled behind the scenes for us. There's nothing that we need to change in order for this to work. So like I said, we've been writing these scripts that use standard in, standard out, and standard error without having really to set that up at all, because it's all already managed for you by the kernel and by the parent process that launched the current process. But the point here is, for us, and when we need to use these things as system administrators, is that these commands can be connected together to build very powerful composites. So this is the benefit. These can be connected together. These standard in, standard out abstractions are handled by the kernel, and then we can actually manipulate them as users. And these composites that I'm talking about are built using what are called redirections. That's the first sort of composite we can build, and also pipes. So redirections go from a process to a file. So we can direct, for example, standard out. We can direct that to a file instead of to the terminal. And pipes allow us to connect processes to other processes. So we take standard out, for example, of one process and connect that to the standard in of another process. So we're going to be looking at how we can use these ideas based on standard in and standard out to build these composite applications. These are where shell scripts and shell scripting languages like Bash and SH become extraordinarily powerful, because now we can harness all of the commands that are available in Linux and also not just use them on their own, but chain them together to produce some really powerful and very useful scripts.